Hello, in this video I want to go over example 3. This is the modeling with recursive sequences worksheet. So in this scenario we're looking at a certain town in upstate New York. It has a small population of 9,000, but that number is decreasing by 1.5%. So I want to write a recursive sequence to model this scenario. Alright, as always, n is going to represent time. In this case, our time increments will be in years because of that 1.5% per year. And Pn is going to be the population of the town in New York after n years. All right, I'm just going to highlight my answers in blue here. All right, and symbol for old population, we're going to use that P subscript n minus 1. And for new population, that's P subscript n. Just keep in mind that's old population. And then we're going to use that old population to then model the new population. And what's the change? Well, now we're going to decrease by 1.5%. So I'm going to make this a minus 0.015 times P sub n minus 1. All right, we're shrinking, we're going to take away, we're going to decrease 1.5%. So note a couple things here. It's a negative, and then that 1.5%. Make sure you convert to percentages correctly, percent to decimal. And then we use this to put together the recursive sequence. P sub n equals. So again, think about this as the new population is going to be the old population, P sub n minus 1, and then the change. In the change in this case is a minus 0.015 times the old population. So hopefully you're getting kind of a hang of the intuition of these types of recursive sequences. You think about this as, well, the new population is going to be the old population. Almost always have the old population or old amount, and then plus or minus the change. And the initial condition in this case is going to be P subscript 0. That's kind of the starting spot, and it starts with 9,000. That's the current population. All right. So what I want to do is, using this recursive equation and initial condition, I want to use spreadsheet software. Let's say I'll first do this through Google Sheets and then Excel. I'll show through both software systems how we can figure out, well, how long it's going to take until the town has a population of, say, 4,000. It's a decreasing population. Assuming we stay at the same rate of decrease, how long does it take, or how many years? So let's go to Google Sheets first. I'm going to click a plus down here on the bottom right to start a new sheet. Let's see, I'm going to say years, and for part B, this is going to be population. Years, let's do 0, 1, 2, 3. And let's see, I'm going to highlight a couple of these, hover on the bottom right corner. Move down. All right, and we don't know how far we need to go, so I'm going to leave it just at 13 years or so. Let's start with the initial population of 9,000. It's a bit larger. And then I need to enter in my recursive sequence here. So how does the population change? You take your old population, 9,000, subtract 0.015 times your old population. So once again, old population minus year decrease, 0.015% times the old population, and you lose a little more than 900, or 1% would be 90 people. All right, so a little more than 90 people are lost. And right here, once I have this cell with the equation typed in, make sure that's highlighted. Have your mouse on the bottom right, and you can double click. And then we can see how this population decreases over time. All right, so what I want to do is figure out, well, how long it's going to take to get to 4,000 in the population. So I'm going to highlight. Really, you can highlight as many as you want. you want to highlight at least 3 or 4 from the bottom, and make sure to highlight both the A column years and B column population. So I'm going to highlight the bottom 4. You could highlight the bottom 4 or bottom 3. And then when you have your mouse over that blue square on the bottom right, click, hold your mouse down, and then drag. Notice both columns, the years, the A column, and the population change at the same time. So I need to keep dragging this down until I get to 4,000. All right, so I got to 60 years. I'm less than 44,000. So right here, after 53 years, population is 40,000, 40 about, if we round up. Next cell down, let's say after 54 years, population is less than 40,000 or 4,000. I'll say for the first time, because afterwards it keeps shrinking and shrinking, but it takes 54 years. It takes 54 years for the population to reach 4,000. All right, so we can do the same exact thing in Excel. We should get the same exact answer. 54 years. So I'm going to open up an Excel spreadsheet. This is the one we have from before. So I'm going to click on the plus sign. Make this a little bigger so you guys can see. I'm going to start with years and population. 1, 2, 3. Population, we started at 9,000. And that's in the second cell down, equal sign, the previous population, minus 0.015 times previous population. Go back and highlight that cell that you entered the formula. Hover on the bottom right of the green square until you see a black or white plus sign. Double click or click and drag. And now here I'm going to highlight the first 3 years and the first 3 populations. Highlight all of these cells. I'm going to click and drag, and we should see as I click and drag this down, both the years and population are changing. And we should get to 54 years. The exact same value right here. 53 years, there's that 40,040. And then 54 years later, the town it goes less than 40,000. It stays with this population decrease.